everyone. This is our 7th lecture of Unit 3 Divisibility Theory and Canonical Decompositions in the paper 19 MA 212 Algebra and Number Theory. So let us have a recap of the previous lecture. In the previous lecture, we are discussed about using canonical decomposition for finding the GCD. Also, we discussed another method, regression, for finding GCD. In this lecture also, we are going to see about for finding these GCD problems under the Euclidean algorithm by using Euclidean algorithm. So this is also another method of finding GCD. These are all the methods for finding the GCD in variety of problems. Let us have Euclidean algorithm. General thing. Suppose A and B are positive integers with A greater than or equal to B. If A is equal to B, then A comma B is equal to A comma A is equal to A. So assume A is greater than B. Then by successive applications of division algorithm, we get A is equal to, suppose they are given two numbers, here A is greater than, any one of the number is greater means we are taking that as dividend and B as a divisor. So that is the meaning of this one. It's like an the previous we are having the divisibility algorithm, no? So that formula only we are using here, but we are going to apply the successive application. So next, after that, after completing the first step, we are taking the previous step divisor as a dividend here, and we will get another in this remainder, no, that is the divisor. So likewise we are continuing. So this will come here dividend and the previous remainder as a divisor. Likewise the process continuing until we are getting the zero remainder. So therefore the sequence of reminders terminate with remainder 0. Thus A comma B is equal to Rn, where Rn is the last non-zero. So we are taking this non-zero reminder as the GCD of the given problem. But we need to continue up to the zero reminder. The previous step we are having on non-zero reminder, no, that is our final GCD. So let us have the problems under this category. So the first problem, find the GCD of 414,662 using Euclidean algorithm. So we have to find the GCD of these two numbers. So here first we just want to look upon which one is maximum. Here 662 is the greater value. So we must have this as the first dividend, this as divisor. Keep the smallest one as divisor. That is the basic concept. The bigger one as the dividend. So let us have the divisions here. 662, the divisor is 441. I will get the remainder is 248. The quotient is 1. Of course, for the second step, we need to take this divisor as the dividend and this remainder is the divisor. Likewise, we are continuing. Here I will get the remainder 116. Keep this as the third step divisor and take this 248 divisor as the dividend. So next I will get the remainder 82 as the divisor here, and this divisor 166 is the dividend. In the next step, this 82 is the dividend and this remainder 2 is the divisor. And finally I will get the remainder 0. You have to stop here itself. Now we are developing the steps. Applying division algorithm successively, we get they are given 662 and 414. We are taking 662 as the dividend, first dividend, and 414 is the divisor. So by the division algorithm, we are writing the step dividend is equal to quotient into the divisor plus the remainder. The first step we are having the remainder 248. Yeah, of course I'm taking that here. Now this as the divisor as the dividend in the next step, and it will come into the 248 come into the divisor. Look, we are seen in the previously, no? So likewise we are taking, so this 248 as the dividend and 166 as the divisor. I'll get in this case 82 is the remainder, quotient is 1. So likewise that we are continuing the process here. In this 166 is the dividend and this 82 is the divisor. In this case I will get the remainder is 2, quotient is also 2. So next here the dividend is 82 and the divisor is 2. It is not possible, so I cannot divide this 2 by using this 82, so therefore I will get the remainder 0. So of course we will get the last non-zero remainder is the GCD. Here I am having the last non-zero remainder is 2. So in this case the GCD of the given 2 number is last non-zero remainder, that is 2. Likewise we need to find the GCD by using Euclidean algorithm. So find the GCD of these two numbers using Euclidean algorithm. We have to find out GCD. First check whether first or second one is maximum. Yeah, 3071 is the 76 is the 3076 is the maximum. I'm keeping that as a dividend, and 1976 is the minimum. I'll keep that as a divisor. I'm doing the same process like the previous step. Here I will get the first step remainder as 110. Keep that as a divisor of the second step, and this particular first step divisor become dividend. So I will get the remainder 876 that will come into the in the third step, that will come into the divisor, and the second step divisor become dividend. Here I will get the remainder 224. This will come into the divisor and this 876 as a dividend. I'll continue the process until I'm getting the 0 remainder. So now applying the division algorithm, so I will get the steps one by one. 3076, here I will get the remainder 1100 and the divisor is 1976. So therefore here the remainder is 876, that is the divisor of the next step. This divisor become dividend of the next step. So continuing the process, so here 224 that become dividend, 204 that is a divisor. In this case I will get the remainder is 20. 204 is the dividend, this 20 is the divisor. I will get the remainder 4. Again 20 is the dividend and this 4 is the remainder. In this case I will get the remainder as 0. So therefore the last non-zero remainder is 4. So therefore this is the GCD of the given two numbers. So next the same thing, evaluate this GCD value. Also we need to write this, of course evaluate this particular one or find GCD of this particular number by using Euclidean algorithm. So apply the division algorithm with 207, larger of two numbers. Among this larger values 2076 as the dividend and this as the smallest one as the divisor. Continue this procedure until a 0 remainder is reached. So first I am taking this bigger one as the dividend and the smaller one as the divisor. The first case I am getting the remainder is 300. Like the previous problems, I am continuing the process. At finally I will get 12 in the fourth step. This divisor become dividend and this 12 become divisor. 24 divides 12 divides 24, it will come the remainder is 0. So therefore the last non-zero remainder is 12. GCD of the given numbers is 12. Using Euclidean algorithm, express these two numbers as a linear combination of themselves. First, before writing the linear combination, we must want to find out the GCD. Then only we can express this as a linear combination. So, before we move on to the GCD, first we need to find out the bigger one. So, 1976 is the bigger one comparatively. So we are doing the same division process until we are getting the zero remainder. So therefore it gives, after applying the division algorithm, I will get 1976 is equal to 1 is the quotient, 1776 is the divisor, and 200 is the remainder. In the previous slide we are having this. So like successive process continuing until we are getting the zero remainder. Here 8 is the non-zero remainder, right? So therefore 8 is the GCD of this particular numbers. Now we need to write the given two numbers as a linear combination. For that, using the above equations in the reverse order. So for finding the GCD process, we are following some steps now. So in this itself, we are going to follow the reverse order. So using the above equations in reverse in order, substituting successively for remainder each time we get. So 1976 comma 1776 is equal to 8. We are getting this GCD value is 8. So look at this. 8 value is equal to 176 minus 7 times of 24, right? I am replacing that value in place of 8. 8 is nothing but 176 minus 7 times of 24. So next I am replacing this 24 value. Don't multiply these two. At fine known in any other step, don't multiply these two numbers. 7 times of 24. 24 is nothing but 24 is equal to 200 minus 1 times of 176. I'm replacing it here. You just look at the same numbers repeated means we just combine that to 176, here also 176, here one time, here minus into minus 1. So here minus 7, here minus, so therefore plus 7. So 1 plus 7 is 8 times of 176 minus 7 into 200. Look at the next remainder, 176. 176 is equal to 1776 minus 8 times of 200. Yeah. Substitute this 176 value 1776 minus 8 into 200. Next look at this, 200 is repeated here. 8 into 8 is 64. 64 minus 7, here minus, here minus. 64 minus 7 is minus 21, 71 times of 200. So look at the previous one. We are having 200 value is 1976 minus 1 time of 1776. Substitute that into in place of 200. So in this particular place, I will get minus 71 times of this value. So therefore combine all those things. 8 times here plus 7 times, this become 8 71 times. 8 plus 71 times is 79 times of 1776 minus 71 times of 19 plus 76. Linear combination is nothing but something is equal to ax plus b form. So therefore I'm just rewriting this minus 71 into plus minus of 71. Likewise we need to keep. So therefore GCD is a linear combination of the numbers itself. So this is the linear combination of the given two numbers. So let us have the next problem. Here also we need to write this as a linear combination by using the Euclidean algorithm. So we have the bigger one is 4076. We just keep that as the first dividend, and by using the divisor 1024, we just want to divide this one. First remainder is 1004. Keep that as a divisor and the first divisor as a dividend. I will get the remainder is 20. So we are continuing the process until we are getting the zero remainder. So we are developing the lines by using the previous division process. We are getting the steps or like 104476 is equal to 3 times of 1024 plus 1004. So etc. So before getting the a zero remainder, I'm having the non-zero remainder is 4, right? So therefore here non-zero remainder is the GCD of the given numbers. Now we need to write the linear combination of these two numbers. For that I am taking the last step. 4076, 1024 having the GCD is 4. So from this step I can able to find out the 4 value. 4 is equal to 1004 minus 50 of 20. So in place of 4 I'm replacing that. Next I'm going to replace 20. So 20 is nothing but here 20, not 2. So 20 is equal to 1024 minus 1 time of 1004. So here I'm having 1004, here also 1004. I'm just combining these two. 1 times, here 51 times. So therefore 51 times of 1004 minus 15 times of 1024. So what is the remainder? 1004. 1004 is a reminder. I can able to find out 1004 value. 1004 is 4076 minus 3 times of 1024. I'm replacing that value here. After replacing that, I'm just combining all those things. Here 3 times of 51 and plus multiply 3 times of 51 minus this 50. Altogether I will get 51 times of 4076 minus 203 times of 1024. I'm just rewriting this as plus of minus 203. So therefore this is a linear combination of the given numbers 1024 and 4076. So still we covered the GC for finding the GCD by using the canonical decomposition and by using the regression method. In the previous lectures we would have seen these two methods. In this particular lecture we are discussed about the Euclidean algorithm. For this also useful for finding the GCD, also for writing any two numbers by using GCD in the linear combination. So these are all the things we covered under the GCD. So in our next lecture we are going to see about the LCD, least common divisor. Thank you everyone.